So this video is all about ionic compounds and how to write ionic equations. So hopefully, by the end, you should be able to work out the formula for a range of ionic compounds from their names, and from that be able to write ionic equations through 4 simple steps. So unfortunately, the first thing you need to be able to do for this process is to memorize a whole series of ions. So I'm not going to go through them all, you can just pause and have a look at them, but these are the ions you're expected to know for the AS exams. So these are the cations. You can see all of group 1, 1 plus, all of group 2, 2 plus, group 3, you need to know aluminium, which is 3 plus, and then several from the D block. Note here that the likes of copper, iron, can have different charges depending on the compound. And you also have ammonium at the bottom. Here are the anions you need to know. So group 7, the halogens, or the halides, sorry, are all 1 minus. The group 6 ions, 2 minus. And you need to know nitride, which is N3 minus. Now they're all fairly straightforward, but you also need to know a whole set of polyatomic anions. Now some of these you will already know from your previous studies, some of them will be new. As you go through the year, you'll notice that you use some more than others, but given that they say you might need to know them, it is best to memorize all the ones I've written down. So again, I'm not going to go through them, but have a pause and have a look through. So once you've memorized all the ions, you need to be able to use these to write the formula for ionic compounds. Now, this may appear difficult, but it is so easy. I've actually got a maths teacher to tell you how to do it. So you better be able to do it.
Hi folks, Mr. Miller here. I'm going to tell you how to write down the equation for the ionic compound when you know its name. So example 1, we have calcium oxide. So you should know that the formula for the calcium ion is 2 plus and the formula for the oxygen ion is 2 minus. So we have the same number on each charge, so effectively we just need one of each of these. We need 1 calcium, 1 oxygen, the 2 plus will combine with 2 minus, and our formula is going to be CaO. Okay, the next one has a bit of a clue. This is iron 3 oxide. Now the 3 is a massive hint for you. So you know that iron is Fe. The 3 tells you that this must be 3 plus. As you know, in general, the metals normally take the plus. We have oxide, so as before, this is 2 minus. Now this time the numbers are not the same, so we need a way to know where to put the numbers when we write the compound. So this is called the swapping over method. If we have 3 plus here and 2 minus here, then what we do is we say Fe, we take the number from the oxygen and it goes to here. We take the number from the iron and it goes to there. This is called the swapping over method. So the formula for iron 3 oxide is Fe2O3. We'll do one more, which is calcium phosphate. Well, as we had before, calcium ion was Ca2+. You should know that phosphate is P big O 4, and the charge on the phosphate ion is 3 minus. So as you know, phosphate is what's called a polyatomic anion. So when we combine these, you need to make sure that we have Ca, we have PO4, and you've got to put a bracket around your polyatomic anion. We need a 3 because we're going to use the swap over method, and we have a 2, so this 2 goes to here. So that's not very clear, so I'm going to write it again. Ca3 bracket PO4 2. And that is all you need to know.
Right, thanks, Mr. Miller. Okay, so once you have the formula for the ionic compounds, you then need to be able to write ionic equations. Now, ionic equations basically show us exactly what is reacting in a chemical reaction involving ionic compounds. Now, there are 4 steps to writing ionic equations. So we're going to go through these 4 steps and then go through an example. So the first one is just to write the full chemical equation. The second step is to balance it. This is very important, or you're going to have wrong amounts of ions at the end. The third step is for all dissolved ionic substances, you separate out the ions. Now, for pure solids, liquids, gases, you leave them as you've already written. You do not separate them out. Even if it's an ionic solid, if it's not dissolved in water, you don't write the ions separately. And then you cross out what are called spectator ions. This is when there is the same ion on both the left and right hand side of the arrow. Okay, so this should make more sense if we look at an example. So the example we're going to look at is a precipitation reaction between ammonium phosphate and calcium chloride to produce calcium phosphate and ammonium chloride. So step number 1 is to write out the equation. If you're unsure about how I got any of these formula for the ionic compounds, look at the previous section and look at the previous slides which tell you the ions. So we have ammonium phosphate solution plus calcium chloride solution. Now this makes calcium phosphate. Now because this is a precipitate, it means it's a solid, and we also have ammonium chloride. Okay, that was step number 1. Step number 2 is to balance the equation. Step number 3 is probably the hardest bit, and that is to write the ions separately for each of the dissolved ionic substances. So we start with the ammonium phosphate. 6 ammonium ions. Plus 2 phosphate ions. We then go on to the calcium chloride. So we have 3 calcium ions. Plus 6 chloride ions. Now the calcium phosphate is a solid. So even though it's an ionic solid, we don't write the ions separately. So we leave it exactly as it is. Or the ammonium chloride is Oops, I've forgotten the state symbol on that. Cardinal sin. Okay, so we have 6 ammonium ions and 6 chloride ions. Okay, so we've only got one step left, and that is to spot any spectator ions. These are ions which aren't actually involved in the chemical reaction. Therefore, they're going to be the same on the left and right hand side of the arrow. So here, you can see we have 6 ammonium ions on both sides, so we can get rid of those, and 6 chloride ions on both sides, so we can get rid of those. So, step 4, the final step is to write the ionic equation, which in this case is 2 phosphate ions. Get the state symbols like I did before. Plus 3 calcium ions makes calcium phosphate. So you should have an equation which balances both in terms of atoms and also in terms of charge. And you can see this one does. So this is what's actually happening in that chemical reaction. The phosphate ions are reacting with the calcium ions to create calcium phosphate. The chloride, the ammonium ions, they're not actually doing anything. And that is the point of writing an ionic equation. So hopefully, you should now be able to write the formula for a range of ionic compounds, or at least once you've learned the ions from the first few slides. And you should know the steps to be able to write ionic equations. Okay, thank you for watching.